Okay, 8.1, complete the square lesson 2. Now we're actually going to do the full complete the square process. The first thing that we have to review is what we call a perfect square trinomial. And in order to learn how to solve a quadratic equation by completing the square, we will use perfect square trinomials and its patterns. So in blue here, I have written a perfect square trinomial the way you would actually take a look at it. We have x plus 3 squared, and we have to remember that this means x plus 3 times x plus 3. And when you multiply these, there actually is a pattern to that. When I do x times x, I'm going to get x squared. And then I have x times 3, so that's plus 3x. And then I have 3 times x, so that's plus 3x. And then I have 3 times 3, and that's plus 9. Now, a key important piece to remember is the fact that when you have distributed all your multiplication, you now have a doubled term in the middle. The middle has plus 3x and plus 3x. This is an important factor for this. So now I have x squared plus 6x and plus 9. But it's a key component of this is that our last term is a perfect square, our first term is a perfect square, our middle term is actually taking, when you have this x plus 3 squared, is taking these two terms, x times 3, or to give you 3x, and then doubling it. So you'll watch as we go through this now, you'll see how this works. So why don't you write down the first example. In our first example here, we have x squared plus 8x equals 1. Now, when you work and do the complete the square process, you will want things may often will look like this. At some point, you'll have something where you have an x squared plus the middle term, and then the third term has been moved to the right side of the equation. So what do we do now? Well, we have to keep in mind, we're going to start with this idea of having that been a middle term doubled. We want to create a perfect square trinomial over here. So mentally, what I want to do is, all right, what's 8 divided by 2? Because that means something was doubled to give me 8x. Well, 8 divided by 2, that's 4. All right, so now what is 4 squared? 4 squared is 16. So if I follow the pattern from over here, we had 3. My middle term here is 6. 6 divided by 2 is 3. That means I had 3x and a 3x was added together. And 3 squared, because I did 3 times 3, gave me 9 on the outside out here. So now what I've done here, middle term divided by 2 to find out what was doubled. That number that was doubled to give me a middle term was squared to give me the third term in the perfect square trinomial. So what do I do with this 16? I will actually add it to both sides. So I say x squared plus 8x plus 16 equals 1 plus 16. Since I've added it to both sides, I haven't changed the value of the equation because I've added the exact same amount to both sides. But what I have created on the left side of the equation is a perfect square trinomial. So how do I deal with it from here? Well, the nice thing is now I'm going to take this perfect square trinomial and I'm going to factor it back into something like this x plus 3 squared here. So again, I know a middle term, 8 divided by 2 was 4. Well, that then tells me what to put inside the parentheses. I'm actually going to write x plus 4 squared. What's that equal? 1 plus 16 is 17. So now over here, I need to just to show you that yes, this is correct. X, if I have this, x plus 4 times x plus 4, the first term squared, x squared. Last term squared, 16. 4 times x, double it, 8x. So now I have x plus 4 squared equals 17. You're now back to what you were doing using the square root property that you did in lesson 1, and I'm going to square root both sides. Excuse me, and I have x plus 4 equals plus or minus the square root of 17. Now x, I'm going to subtract 4 from both sides, so I say x equals a negative 4 plus or minus the square root of 17. And at this point, then I'm going to stop, because now the square root of 17 is an irrational number. I could continue on here, and then if I did, I would use a rounded number for the square root of 17. So let's take a look now at problem 2. Problem 2 says y squared minus 5y plus 2. All right, so do I have a perfect square trinomial there? No, I don't at this time. Because when I have the first term has to be a perfect square, which it is, but is my third term a perfect square? 2 is not a perfect square. But now I'm going to try to complete the square. So I have a problem that I can factor like I did number 1. So what do? First thing is we're going to make this example 2 look like example 1 by moving the 2 over to the right side of the equation. So what do I have now? I then write y squared minus 5y equals negative 2. So now I have moved it over. I move that over to the other side to help me create a perfect square trinomial on the left side. Next, I'm going to say, all right, this is my middle term. I have to figure out what was doubled to get this middle term of minus 5y. Well, that would just essentially be saying 5 divided by 2. Well, that equals 5 halves. I'm just going to leave it as 5 halves. It works to our advantage to leave it as a fraction, as an improper fraction. All right, so then 5 halves has to be squared. So if you square 5 halves, what do we get for an answer? What we get is 25 fourths. So that is the amount that I'm going to add to both sides. So I'm going to say that y squared minus 5y plus 25 fourths equals negative 2 plus 25 fourths. Next step, what do? Well, I'm going to combine my like terms on the right side of the equation, and I'm going to do this factoring into a perfect square trinomial like this. So now let's take a look. The advantage of using this is when I find my middle term doubled, that will always be what goes inside the parentheses for my factoring. So then I have y, and what was the number I put in there? It was 5 halves. In this case, I will write minus 5 halves. The reason for that, when I look at my middle term is what? Negative. So that means a negative inside my factoring and inside the parentheses. So I have y minus 5 halves squared equals, now, negative 2 plus 25 fourths. Let's take a look at that. Negative 2, let's see. If I put that in terms of fourths, negative 2, that is the same as negative 8 fourths. So I want to take negative 8 fourths plus 25 fourths, and it gives me 17 fourths. What's my next step? Well, next step then is, all right, square root both sides, and I would get y minus 5 halves equals plus or minus the square root of 17 fourths. Now I'm going to add 5 halves to both sides, so y equals 5 halves plus or minus the square root of 17 fourths. Lastly, I'm going to use 2 more steps. I am going to use my quotient rule, and I am going, oh shoot, my fault. There we go. I am going to hit the wrong button. Sorry about that. I'm going to use a quotient rule over here with the square root of 17 fourths. What am I going to do? I am going to just say the square root of 17. That's like the square root of 17 over the square root of 4. So y equals 5 halves plus or minus the square root of 17 over 2. And since I have a common denominator here, I'm going to say y equals 5 plus or minus the square root of 17 all over 2. And then I'm done at that point. And I can't simplify any further with this one because I still have an irrational number. Understand this, one other thing for a side note for you, that if you get to a final answer that looks like this, 3 plus or minus the square root of 16, you get something that looks like that. Well, the square root of 16 is a perfect square. So I would then change that to 3 plus or minus 4. And since now that I have integers, I'm actually going to do what is 3 plus 4. I'll break it apart into two little problems, 3 plus 4 or 3 minus 4. And I get answers of 7 or -1. So sometimes you'll get an answer that's going to have an irrational number in it. You can just leave it like this. If you get one with a perfect square in it, simplify it as far as you can, get it down to the actual numbers. Okay, so what would I like for you to do? I would like for you to turn the book open to page 4, and I believe this is on 480. Does it start 488 or 487? 487. And we're going to do numbers 35 through 41 odd, and then we're going to do 49, 51, 57, and 59. So please turn this in when you get done with it. Be sure that you show your work. There's a lot of steps to show. Take your time with it. It's that idea of trying to create the perfect square trinomial using some factoring concepts, using your complex numbers or irrational square root properties that you've used all in the last chapter. Okay, this video is long enough. Please go ahead and get to work on it. I'll help you as you need it.